Date is 1/27/14. Do we remember what a polygon is?
Four sides.
No.
Five sides in the picture. Oh, that's that? Yeah, you need to focus on. Three sides are here.
Polygons have sides and angles. For instance, what kind of polygon is this? How would I categorize that? Don't write this down, just tell me. How, 1, 2, 3, 4, 5, 6. That's a hexagon. That's a convex hexagon. What kind of polygon is that?
Concave.
Because it caves in, right? But for the most part, we're going to deal with convex ones. Okay? Polygons have sides and angles. Angles determine what? You guys remember? Shape. Sides help determine what? The what? Not the sides, but the size. When polygons are, what's this word mean? Or what's that symbol mean? Congruent. Then they possess the same what? Size and what? Shape. This is all review, right? Bean, what's in your ear? It's not on, is it? Okay.
What does it say after the day?
What?
Then they.
Possess. Is that one S?
It's supposed to. I think it's POSSESS. That's what I put. One more S at the end.
That doesn't look right.
There's only one. It's POSESS. Too complicated.
That's what I mean. We know what you mean. We know what you mean.
Well, yeah. The people on YouTube don't.
They can hear my voice too.
That's posse.
See, look into that
The
section.
posse. Typing it on his phone.
Where I hold my
POSSESS.
POSSES. Kayla got it right.
The same shape and size.
Bless you.
Okay? However, well, here, below same shape and size in parentheses, same what? Sides and what? Angles. Right? So that when they're congruent, they have the same sides and angles. Everybody agree there?
Yes.
However, when two polygons are said to have the same, or said to be similar, they just have the same shape. Not size. So to add to that, when things are congruent, they have congruent what? Angles and congruent what? When they are similar, though, what did I say? It's the same what?
Shape,
What does shape deal with? Is that the angles or the sides?
sides.
Angles.
What does it say up there?
Angle.
Angles determine the what?
Big.
Sides determine how big that shape is, right? So similar, what do they say is the same? Shape. So they have congruent what? Angles and non-congruent sides. So that's the difference between when I say two polygons or triangles or whatever are similar, or if I say they are what? Congruent. When they're congruent, one's the exact copy of the other one. You know what it is when they're the same shape? You guys ever heard of shrinky dinks before? They were little pieces of paper that you colored when you were a kid. Or at least I guess my wife tells me about them. I never did them. But you like had the shape and you took your crayon, you colored it, made it look pretty, stuff like that. Then you put it in the oven, and it shrunk down to the exact same size, and it always looked prettier because the colors kind of condensed into it. You know, if you colored it red, it was now a deep red, and it got smaller. But the shape was the exact same, wasn't it? Let's say 50%. So they were the same shape, they just shrunk, right? How many times, it was more of a girl thing, how many times have you gone to, if you've ever gone to a copy machine and pressed 50%, it's going to make it half as big as what you have, right? I don't, am I discussing shrinky dinks to have you mess with your phone with it? You really have to ask that question. Now, if you put 50% on the copier, you know, it makes that shape, whatever you got in the copier, it shrinks it to half size, right? So here's the thing, though. If the sides were 4 inches long, and you put 50%, what do you think the sides are now?
2 inches long.
Half as big, right? But you know what stayed the same? All the angles. Because that's what makes the what? Shape. What makes it look a certain way. And that's what you have to understand about similar. And the other thing you have to remember is there's also, though, we're going to say proportional sides. That 50% that I just said to you, in other words, you made it half as big, right? That's how the sides are proportional. One is half as big as the other. So if one side was 10 on something similar to it, if it was half smaller, what would it be?
5.
The length of the length of one copy of it would be 5. You know, to make an example of that, you know, we could draw two triangles. Triangles are kind of the easiest to draw, and I'm going to try to draw one that looks about the same. No, just watch. About the same, except just smaller. Call this A, B, C. We'll call this D, E, F. What you got to know is that this angle is congruent to what? So A, C is congruent to what?
D.
And B is congruent to what?
Yeah.
If these are what?
Similar.
But how are the sides going to relate to each other? Well, here's how I'm going to tell you a way to find out. Right now, I'm going to say the length of this side's 9. The length of this one is 6. I'm going to say the length of this one is 12. Then I'm going to say this one is X. I'm going to say this one is 15. And I'm going to say this one is Y.
They're not similar.
No, I said they are. These two are similar. Okay? We're going to find x and y. Here's the deal. This one's, if they're similar, then this one has been shrunk a certain amount, whether it's 50% or whether it's twice as big, whether it's a third as big. The key to this is to realize that here's the deal with similar polygons. This one over this one will always equal, the ratios of the corresponding sides will always be the same.
So we set up proportions.
Yep. The ratios of corresponding sides will always be equal. That's that 50%. That's the shrinking it, oh, I don't know, 80%. Put the phone up, please, if you don't want me to own it. That's making a third bigger, making it, you know. What stays the same are these angles, because that's what makes its shape. What determines how big this triangle is the sides. This side's 9, this one's 12, this one's 15. Okay? Here's the deal. Which side corresponds to AB?
EF.
So I know that 9 over 6 would equal the same ratio of this one. So I went with the bigger over the what? Smaller, right? So let's start with here. 12 over x.
And it doesn't matter what order we do it in either, does it? We could do 6 over 9.
You could do 6 over 9 equals x over 12, but you could not do 6 over 9 equals 12 over x.
Keep it the same.
You have to keep your, you know, if you're putting your big triangle on top here, with your proportion or your ratio on the other side needs to have what? The big triangle on top. This ratio has to be the same. So what you do, and why do you think 7-1 we did what? What was 7-1 about again? Ratios and proportions. You know why we did that? Just to remind you how to solve these equations, because that's basically what you're going to do with similar figures. The ratios, the ratio of this one to this one is 9 to 6, because these ratios have to be the same. So you cross multiply and solve and you get 9x is equal to what? Huh? 72. Divide both sides by 9. What did it get x to be?
No, 8.
Oh, yeah.
8.
Sorry.
Now, how am I going to find the other one? Guess what? I have the ratio of the corresponding sides. It's 9 to what? But instead of going 12 over x to find the other one, I could do what? 15 over y, because this one corresponds to that one, right? Cross multiply, you get 9y is equal to 90. Divide both sides by what? What'd you get y equal to? That wasn't too bad, was it? The last thing to talk about here is what is called the scale factor. What do you think the scale factor is here?
Probably has something to do with figures being scaled.
How many, I'm running out of room here, but we ought to be able to, what about the ratio of, what's the ratio to the corresponding side? It's 12 to what? What was x?
8.
Come in. When you reduce that, what do you get? Come in. What is 12 over 8 reduced to? 3 over what? 2. Does everyone agree? Let's look at another one. We just did, let's do 9 over 6. What does it reduce to? 3 will go into that what? 3 will go into that what? What does 15 over, what was y? 10. What does it reduce to? What was the same?
The ratio.
The ratio. So you know what your scale factor is here?
Wait,
Because the ratio of the corresponding sides when reduced always was 3 to what? 2. 3 to 2. If I asked for the ratio of the smaller side to the larger side, what would the ratio have been here? Or smaller triangle to the larger triangle, what would the ratio have been here? 2 to 3. Make sense? That's similar polygons. The angles will always be the same if they're similar, and the ratios of corresponding sides will always be equal. So you know, basically what you have to do is find a ratio you have, right? 9 to 6 was our kind of golden ratio, I guess you could say here. Our ratio that made a scale factor of 3 to 2. Then you just, if you have one of the others, you can make the other one X or Y or Z or whatever, and you can solve them. Everybody gets your little red books. That's what similar figures is all about. Understanding the concept of similar figures will help you so much more than trying to memorize what it is. If you just understand that it's a shrunk down version of the exact same thing, and that the sides have to relate to each other, that the ratios are equal, it's really not that bad at all. You know, look at this one. How are they going to try to confuse you sometimes? What do you think they're trying to do here with number 1?
wait, what page are you on?
Looks like 86.
Correct. It is 86.
What are they trying to do to you here? Can anybody tell me?
They're trying to confuse you
How?
because they have it like different.
They kind of flip-flopped everything, didn't they? It's not the one on the bottom one. If it helps you, redraw the little one. So, which one is this side right here? That's 8, isn't it? Looks like it was just turned like that, right? So what does this side become? This side becomes what? Okay. Now, which ratio do you have? Which 2 do you have where you can find your ratio to find the other 2? Do you have 12 and 8? So 12 over 8 is equal to, now I just need to, let's see, I did the big one first, so 9 over what?
X. 12x,
12x is equal to what? 72 divided by 12. What'd you get? They asked for anything else?
No.
Could you find anything else?
The similarity statement.
Scale
reasoning.
Scale factor.
Oh, sorry, that's the wrong page. Find the value of x. That's it.
We could find the scale factor though, couldn't we?
Yeah, scale factor is what? 4 goes in that 2 and 4 goes in that 3. 2 over 3, isn't it? Or 3 to 2.
Yeah.
Any questions there? You guys all right?
Yes.
It's kind of easy, isn't it?
Yes, it is now.
Look at number 2. Are these facing the same way?
Yes.
So it's pretty easy. Do I know the ratio here anyway? I didn't ask that. Do I know the ratio? I didn't ask for the percentage.
10 to 5.
10 to what? So if you go big to small, 10 over 5, you know you have that side. All you got to do is have one of the others to find it. Which one does the x relate to?
5.
Corresponds to the 4.5. Which one needs to be on top, the big or the small? Big, so 4.5 over, now I can cross multiply and solve. 22.5, is that right? Started with a decimal, so your answer is 2.25, is that correct? How easy is that? Now, are they going to try to complicate them up a little bit? Sure. But the concept hadn't changed. Do I have a way to know And another way, when they have them marked like this, it's nice and easy, is you know that how many marks does that have? 1, 2,
4.
the 3 mark, that's,
4.
yeah, that's 4. The 4 mark and the 1 mark make the one that would be, what relates to that? To the 18, the 12. So you, what do you want to make your ratio? 18 over 12. So how did we do it? We did this one to this one. So I want to find this one, what? Here, right? Find x. Which one corresponds to the x plus 1?
24.
Which one goes on top, though, here?
24.
Because I put the 18 on top, right? X plus 1. Thing to remember here, when you cross multiply,
The whole thing.
you have to distribute it through. It's 18x plus 18 when I multiply through here, right? Is equal to whatever 12 times 24 is. What's 12 times 24? I don't know that off the top of my head.
That's too much.
It's 288.
Yeah.
Okay. Now, what are we going to do?
Gotta solve.
So the only difference between this and the others is your equation just ends up being a little more complicated, doesn't it?
Subtract 18 from both sides.
288.
So 18x is equal to 270. Divide both sides by what?
18.
X is equal to what?
15.
Huh?
15.
It just come out nice and even. How wonderful. Okay, look over here at the next one. Anything change? What's my ratio? What do I have that some corresponding sides?
40 to 30.
40 to 30. And for those of you that this confuses you, then just flush it what I say right here. But those of you that see this is real easy, do you realize you could use 4 over 3 too? Because
Oh.
it's still the same ratio. But if that messes with you, hey, no problem making them bigger numbers and go 40 over what? 30, because we all can use calculators, can't we? Okay? This one would be what? X plus 15 over, what does it relate to?
18
And that's what the thing that matters is finding the right place to put whatever in the proportion, doesn't it? Okay. So it'll be whatever 40 times 18 is.
450. Wait, no, I did 30.
720. And so equal to what? 30x plus
450.
450?
Why'd you put x plus 15 on the top this time?
Because that's all.
Because I put 40 on the top. So what's on the same triangle as the 40? X plus 15. If you'll notice on all these we've made,
Maybe we're trying to move a similar triangle.
10 over 5, right? The 10 was on the same place as what? Same figure as 4.5, and you notice they're right across from each other. The 5 was the same place as the what? You see, does that make sense? That's how you can kind of check yourself. The 12 was with the 9. See how it is right here? The 8 was with the what? You see what I mean? That's you just it's got to be like that. So back up to here. Just a matter of solving this, isn't it? What do you get here?
270.
Can we do that?
Yep.
On number 5, they ask you to find the scale factor and the perimeter of each polygon. On number 5, what would the perimeter, or what would the scale factor be? Do I have any that match up? At first, it doesn't look like it. But if this is 25, what did they tell me? This is what?
25.
If this is 20, what's this? This is 14, what's this? Okay. Basically, that's the only thing left for me to find, isn't there? So what's my scale factor? But they asked for the scale factor from ABCD to PQRS, so that's from what? Smaller to what?
Bigger here.
So what needs to go on top?
20.
Now, should this ever be a mixed number? Or decimal? No, we're gonna put it as a fraction. 5 goes into that 4 times, 5 goes into that 5 times, that's my scale factor. And if you find your scale factor first, you can use your scale factor in your proportion, can't you? 4 over 5 is equal to 14 over, but sometimes it's just easier because, you know, because if you do it this way, it's kind of like, okay, where did the 4 come from? Would that matched up with this one or that one, right? It's probably easier to say, okay, 20 over what? 25, 14 over what? Cross multiply. 20x is equal to, what is 25 times 14? 14 quarters gets you how many dollars?
350.
What? No.
It gives you $3.50.
Yeah.
So this is 350. Divide by 20. X is equal to?
Doesn't go any to
Huh? What?
170.
Use your calculator.
But I'm super small.
Oh my.
Was that right? What did you say, Taylor?
It's 170.5.
17.5.
Yeah.
17.5? No, you said 170.
170.
17.5.
Oh.
So,
152 off.
that makes this 17.5, makes this 17.5. So what are the perimeters of the two figures? What's the perimeter of this one? How do you find perimeter, guys? 14 plus 20 plus 14 plus 20. 20. This is 28 together. That's 40, 68, right? 17.5 plus 17.5 gives me what? 35. Plus 50 more makes it what?
85.
And I guess what? If you went 68 over 85, can anybody tell me what you get as a reduced fraction? Use your calculator. Because the perimeters have the same scale factor that the sides do. Because all they are is the sides added together. Your assignment